Thank you. Hello, good morning everyone. It's great to be here and thank you for your interest and attention this morning. And a big thank you to LPRIG for having us along and giving us the opportunity to present today. A few familiar faces in the audience, which is always great to see, but for those of you that I haven't met before, my name's Henry Brocklehurst, joining you from our road asset management team at Vaisala. So the title of the presentation this morning, it's quite a long one I'm afraid, but I'm going to talk about a joined up thinking approach to achieving efficiencies through advancements in highway data collection. So the plan is to talk about some of the advancements and new methodologies in obtaining up-to-date information from the highway environment and a bit about the approach that we've taken to that over the last few years. But also what that's enabled at local authorities around giving a more joined up thinking approach and how they manage some of the different assets that they're responsible for. So Vaisala, or Vaisala as it's usually pronounced in the UK, were founded back in 1936, but we've been active in the UK highways space for around 35 years. A lot of what we do is related to winter road maintenance, providing weather stations and decision support software for winter gritting operations. But for around the last 6 years, we've been working and offering a system called Road AI, which is, as the name suggests, leverages artificial intelligence to analyse video footage that's been collected across the highway network. Specifically, the branch of artificial intelligence that we utilise is called computer vision analysis. And computer vision is concerned with the automated identification and detection of objects or features from across video footage and converting that into useful information and data. It aims to replicate the way that humans perceive the environment around them, and not only how they see that, but how they understand it and how they're able to give context to what they're seeing in that environment. The textbook analogy that we like to use in describing how computer vision works is when considering the difference between a dog and a cat. So bear with me on this. This is a very easy task for a visually able human to determine. You're able to easily identify the difference between a cat and a dog simply because they look different. However, if somebody asked you to describe a dog, you might say, well, it's got 4 legs, it's got a tail, it has 2 ears, and it's covered in fur. Pretty good description, but actually all of those descriptive terms that you've used there could also apply when describing a cat. So in computer vision, what you do, instead of trying to describe to the computer what something looks like, you show it tens of thousands of example images, tell it what's in that image, and then over time, the analysis learns for itself. In reality, that fits together a bit more like a jigsaw puzzle, where each of the individual pixels within that image are analysed and categorised. Whereas a human would know what the jigsaw is supposed to look like based on the image on the box, the computer doesn't need to know that. It's able to derive insights and outcomes itself from what's contained in that image. We use a granular and detailed technique. So you might see AI-based systems that sort of draw a box around objects and features. That's really effective for applications like traffic counting and sort of object detection. But we're able to kind of provide context and look at defects across the road surface and their severity. So we've got a more refined technique around the analysis of that imagery. The approach we've taken specifically in Road AI is that we wanted to provide a quick and easy method for local authorities or their highway contractors to collect their own data utilising existing vehicles on an ongoing basis. So we utilise smartphones placed in any vehicle to collect and update that imagery on an ongoing basis. The phone has everything that we need. It's got a decent camera, it's got GPS location, and it's got an internet connection to seamlessly upload this information to the cloud. At that point, it's analysed using our artificial intelligence and machine learning algorithms to derive insights from that imagery. And then within just a few hours, you'll get those results live in a web-based platform. You can give access to as many people as you like. From there, they can interrogate the data, they can view video footage, and they can export it into a number of versatile data formats in order to apply that data and information. Got a video on this slide, which hopefully plays okay. It looks like it is. So side by side, the raw imagery here with what's being analysed from that video. So this is data being collected at the normal driven speed of the highway. Every individual frame of that video is analysed, and defects and objects are categorised. Basically, everything that you can see in different colours can be converted into useful data and information. It's fairly granular and detailed. We're able to provide analysis of as many different assets as we can from that one driven survey on the highway network. That includes road condition and defects, but also identifying and plotting where all of your traffic signs are across the road network. Also road markings and looking at the condition of the linear line markings. Some really good work and collaboration going on at the moment around utilising this visual assessment of line marking condition. But also defects, so not only around planned maintenance, but trying to join that together with reactive maintenance. So having one data set that you can use across both those areas, trying to bring planned and reactive maintenance a bit closer together, whereas those are often handled quite separately at a lot of local authorities. Coming back to road condition and defects specifically, it's fairly detailed in terms of what the system can identify. And so we're not just telling you what the condition is, but we're telling you specifically what defects are identified and what defects are present, so that you can isolate and feed those defects into relevant programs of work. So the data has been utilised for jet patching programs, potholes. It's been used for haulching programs around edge deterioration, patching programs, surface dressing. I was speaking to our user at Buckinghamshire yesterday. They said that they've got some funding available for crack and joint sealing. From this data set, they're easily able to just identify the relevant defects, feed that into a program of schemes, and then they can begin to validate those schemes from a desktop environment just using that video footage. Additionally, as well as carriageway, we're also looking to survey from footways and cycleways. A huge amount of incentive around active travel at the moment and active travel infrastructure. But ultimately that will create more maintenance headaches for local authorities. So providing a tool where you can collect this information using a similar methodology to your roadways and a quick and easy method to update this information on an ongoing basis. All right, so that's a lot around kind of what we've been doing so far. What we're beginning to look at is connected vehicle data. So the ethos with Road AI has been trying to provide more dynamic methods of collecting and updating information on an ongoing basis from existing vehicles. The next step in that process is looking to leverage data from connected vehicles that are around on the network already. That includes data around road roughness and ride quality and friction, also steering and suspension information from those vehicles that can indicate where you've got obstacles such as potholes. So looking to ingest that data as well. Really up-to-date information from thousands of vehicles that are already out on the network. Also looking to ingest harsh braking data. So that lends itself more to road safety applications rather than road asset management. So really exciting area to be involved in, and we're looking to release more information on this later this year. Okay, so to finish off, I wanted to sort of take a bit of a step back from some of the detail that we've looked at and actually just talk in more general terms around some of the barriers that, or sort of obstacles that are in place when you're looking to implement new technologies at local authorities. Hopefully this will resonate with most of you in the audience, both from a local authority perspective, but also from a supplier perspective as well. It's not as simple as a local authority identifying a solution or a system that they want to implement, and there are often a lot of considerations in place for them to be able to do that. One of the most obvious ones is cost, but cost needs to be a more detailed question than just what's the price. If something costs more, does it deliver a saving or improvement elsewhere? If it costs less, am I getting the same service for that cost? What's the upfront cost? Are there any ongoing costs around support and service as well? Another obvious one that's talked about quite a lot is procurement. We've experienced local authorities that want to implement technologies, but they know that the ordeal of actually trying to procure something and how long it takes puts them off from looking to implement those technologies. We know that this is something LPRIG are aware of, and they're looking to implement their framework. So frameworks can help to assist in implementing new technologies, and some really good work that's going on there. Another one is resistance to change. So often the decision maker at a local authority might be a different person from those that are actually going to be utilising a system on a day-to-day basis. So it's important to get buy-in from all of the relevant stakeholders before looking to implement technology, which makes it a smoother process when you do look to drive the changes. Credibility. So it's a challenge for any new technology to try and achieve credibility, or in fact accreditation within the relevant field. There's a lot of ongoing conversation around the new PAS, or road condition assessment, and the challenges involved in that. I think the main question I have around that is how a new data standard can lend itself to future technologies. We've seen how much technology has changed over the last few years. We're looking to kind of accommodate that within the new data standard. But how can you have a data standard that might lend itself to future technologies and advancements as well? I think is probably the main challenge for the DFT have on their hands with that. Data integration. So with any sort of data providing system, ensuring that data is in easy to use formats, easy to feed it into other software systems, and having a collaborative approach to integrating that data. And finally, risk. So I believe there's a session coming up later today around how to get the best out of AI, being chaired by Sean Rooney. There is a lot to consider for local authorities and potential risks that need to be looked at. And I think it's around putting a process around technologies that you want to implement, getting the right people involved to understand and mitigate those risks. In summary then, the approach we've taken is collecting data from existing vehicles. So whether that's providing devices to collect data from safety inspectors or highways personnel, or in the future looking to leverage data from existing vehicles that are already out and about on the road network. It's around providing more frequent data at less cost in comparison to conventional survey methodologies. Everybody talks about early intervention asset management, and that's pretty unanimously accepted as a theory. Difficult to implement that though without up-to-date information to drive those decisions and actions. Trying to bring planned and reactive maintenance closer together. So if you have a system that's collecting data using your safety inspectors, and you've got tools in a system that can provide data to help them, if that data also provides data that can be used for planned maintenance and feeding forward programs of works, join the two together, less kind of reactive and sort of chasing your tails trying to fix potholes, feed more of that information into planned and targeted programs of work. Providing flexibility and control. So we've got a system that aims to put local authorities in control around collecting and updating this information. rather than having to commission a third party every so often to come and update that data. If there's a section of your road network that you wanted to survey this afternoon or tomorrow, with our system you could go and do that, and you can get the data in just a few hours. A cost-effective system, so new technologies, there's generally an assumption that there'll be higher costs involved. So there's looking at ways that you can develop technologies that streamline costs as much as possible. Cost, being a huge driver at the moment for any technologies that local authorities look to integrate. Finally, and the message that I tried to sort of leave everyone with as a conclusion is to keep it simple. So there's advanced technologies that sit behind a lot of these data collection methods, but having a simple system that enables you to collect data from any vehicle as little or as often as you like, and being able to quickly view and interrogate that data in easy-to-use formats and in an easy-to-visualize platform is the key to the success of many of these technologies. Okay, so I think that's everything from me. I hope that's been informative, and thanks again for your interest and your attention today. We've got a stand at the back near the entrance, so do come and see us if you've got any questions or comments. Enjoy the rest of the day, and thank you very much.